Hello, my name is Aaron Johnson. I work in cybersecurity, doing public key infrastructure technologies deployments and HSM deployments. Today we're going to be looking at SQL transparent data encryption using an extensible key manager that's going to be utilizing the nCipher Solo XC Connect. nCipher XC. So to get started, we're going to be using the database that's available as a download from Microsoft called Northwind. It's a nice database as a demo because it's nice and big, it has lots of different tables, and you can run all sorts of queries against it. So the first thing to do is to create our cryptographic provider using the DLL that nCipher provides. I stored it in the System32 folder because Server 2016 doesn't like to pull these things from the program folders for whatever reason. So once you've gone ahead and created your cryptographic provider, go ahead and verify, give it a refresh, and the naming should match. Next, let's create some keys. But before that, we should probably create our soft card. So soft card is not reliant on a hard card, that's why it's soft, but it is used to wrap these keys inside the security world and protect them. Passphrase here be as long and as short as your organization allows for, and once you've got that created, you're going to go ahead and create some credentials for that. In this case, I'm going to call this the same as the soft card name. The naming convention I chose here is inadequate, but as for a demo, it's fine. You want to be as precise as possible. So we'll map that soft card credential to my login, ARJ, hit add. That's going to give us permission to go ahead and start creating some keys. So let's run this command. Let's run this bit here, this tsql. So we're creating an asymmetric key that's going to wrap the symmetric key that we're creating. And the naming convention DB says you can see it from within the database. EKM says you have to look inside the HSM to see that key. And we get an error. This is by design here because I want to show you, if you see this error, you may have to restart your SQL Server and the service. So make sure no one's on the server as well. You know, most of this stuff should be done off hours anyways, but I'll throw that up there as a caveat. Once you restarted it, you should be able to run this tsql statement here. Okay, successful, we're good. Alright, now let's create the only key we're going to be creating inside the master database. This is the TDE KEK. Using the same provider that we created at the beginning. And let's verify that these keys are in place in the security world here. There they are. Now we got to create some more credentials here. Call this TDE login, and this should be the identity of the soft card and the PIN of the soft card. And we'll map that credential to a login here, so the SQL Server can get in and see that key as well. We'll call it the same. Of course, you want to be more precise with your naming convention so that somebody can come in and see what you're doing here. And map it to that credential TDE login, hit add, and that's it. Now you can turn on encryption. Right click, tasks, manage database encryption. Go ahead and use the AES 256 algorithm and the server asymmetric key that we created, And we're going to have to run a couple of statements here to verify that it is encrypted. So first we'll need to get the database ID. In this case it's 5. Now I'll pull all the encryption keys and see what they're mapped to. There's 5, encryption state is 3. Encryption state tells us it's a number here, but you'll want to go ahead and pull your documentation and verify that 3 means it's encrypted, and it does. So now we have a database that's enjoying TDE, transparent data encryption. But one thing to note is that any data that leaves this server won't be encrypted on the wire. So to verify that's happening, you can use your server authentication certificate, similar to what you do with a TLS or SSL web server, and tell the database to use that for in-transit encryption. So we're going to go ahead and pull up our SQL configuration manager here. And one thing to note when you're using these certificates is a version 2 certificate will show up in configuration manager. In this case, I'm using the same certificate I use for NLA, but you'd want to use a different one. That would be important because you could have it live a bit longer than your RDP certificate, and also if one has to get revoked, the other doesn't suffer as well. So pull up the correct configuration manager. That's not it. The correct configuration manager. And if it is a version 2 certificate, you want to go ahead down to network configuration and hit properties for the protocols, and you should see the certificate pop up here. There it is. If you're not using a version 2 certificate, that's fine. Just add the thumbprint to the database or to the registry yourself. Thanks for watching, and I hope you enjoyed it.